Okay, I'm going to explain to you today the most probable number technique for working out how many bacteria you have in a culture. So let's start off with just a flask of bacteria up at the top here. There's our little flask, and it's got a stopper in there. And here's our culture. Okay, and so when you do the most probable number technique, is what we're going to do is we're going to set up a series of tubes which we're going to inoculate using serial dilution. So I'll start off by drawing out the tubes here. So I'm going to draw 6 tubes here, I think 6 tubes. So there they all are, and let's put some media in them. So there we go, some media in each of the tubes. Okay, so what we're going to do is we're going to take 1 ml out of our original culture there. So we'll take 1 ml of our original culture out and inoculate it into this first tube. And this first tube is going to contain 9 mils of media. So that's a 1 in 10 or a 10 to the minus 1 dilution. Now if we take a ml out of there and put it into this second tube, so let's take a milliliter out, and in that tube there's also 9 mils, so that's another 1 in 10, so this is a 10 to the minus 2 or a 1 in 100 dilution from where we started from. We're just going to keep doing this set of serial dilution, so each time we take out 1 mil and we add it to an existing 9 mils, so that's another 10-fold dilution, 10 to the minus 3. Let's take out another 1 milliliter, and that would be a 10 to the minus 4. Then let's do another 1 mil, and that would be 10 to the minus 5. And let's do another 1 mil just to finish up, and that would be 10 to the minus 6. Okay, so is what we would then do is we would take 1 mil of each of these dilutions, and we would inoculate it into another set of tubes. So let me draw another set of 6 tubes down here at the bottom. So let me just draw 6 tubes. I'm not a fantastic artist, but you get the point. These are 6 tubes. The last one's really bad. So we're going to take out 1 mil from that top tube up there, and we're going to put it into this bottom tube, and then we would do that with 1 milliliter from each of our serial dilutions, and then we would pop those in the shaker, and we'd see which ones we got growth in. So let's just make up a scenario where, let's say in these ones we saw growth, but then in these last two we saw no growth. Okay, so that's what would happen given this setup. So now let's go back and do a bit of a thought experiment here. Let's just make the assumption that our starting culture had 10,000 cells per mil and work forward from there. So if we work forward from 10,000 cells per mil, if we dilute that 1 in 10 in our first tube on the left here, that means that the tube there would have 1,000 cells per mil. And if we took a mil out of there and we put it into 9 mils, we'd have 100 cells per mil. And then if we took a mil out of there and did that 1 in 10, that would be 10 cells. Then the next tube would be 1 cell per mil. And then down here we get to being less than 1 cell per mil. So that would be 0.1 cell per mil. And then we'd have 0.01 cells per mil. So now, if we took a mil out of the tube on the left and we put it into the tube at the bottom and let it grow, we'd have put 1,000 cells per mil in there, so that would grow. And then the second tube there with 100 cells per mil, if we took a mil out of there, we'd be taking 100 cells out, so when we get growth in our bottom tube. And if we took a mil out of our third tube, that's a 10 to the minus 3 dilution, and we put it into our bottom tube there, then that would be 10 cells per mil, so that would grow. If we took a mil out of our fourth tube, that's the fourth tube from the left, we'd be taking 1 cell per mil, and so we'd get growth in our bottom tube. But then if we go to the fifth tube, that's the 10 to the minus 5 dilution, we'd only have 0.1 cells per mil. So if we took a mil of cells out of there, on average, we would only have 0.1 cells. And obviously you can't have 0.1 cells, but on average you'd have 0.1 cells per mil. And so if we put those into this fifth inoculating tube from the left, we need at least one cell to initiate growth, because one cell becomes 2, 4, 8, 16, like we've talked about before. And so there'll be no growth in there. And if we go to the sixth tube, situation's even worse, because in the sixth tube from the left, this one here, there's only 0.01 cells per mil. So if we take a mil of that, on average we only have 0.01 cells. And so again, in our inoculated tube on the bottom, we'd have no growth. So in this kind of little thought experiment, we would have at least 10,000 cells in our starting culture at the top. Now in this setup, it could be anywhere from 10,000 cells to 99,999 cells per mil. And so this always gives you a range. If we had 100,000 cells per mil, then in our 10 to the 5th dilution, we'd have 1 cell per mil. When we took that out, we would get growth in the 10 to the -5 inoculating tube. And so it's got to be less than 100,000, but more than 10,000. Now you can come up with fancy mathematical equations to do this, and you can memorize those equations, but the bomb-proof way to always get these problems right is to work backwards from the dilutions to the number of cells per mil in the original culture. So that's the minimum probable number way of coming up with a range of cells in an original starting culture.